Good afternoon. I think we're near on 12 o'clock now, so hopefully about ready to start this seminar today for a guide to achieving compliant fire stopping. If you've got any questions, if you can pop them, there's only myself on today, so if you pop the questions in the question box and then we'll look at them at the end. I probably won't get to see them as I'm sort of moving through the presentation. It's going to take about 45-50 minutes hopefully, so I'm going to try and crack on through them fairly quickly because there's quite a few slides to get through today. My name is Joanna Strickland. So yeah, if you've got any questions, just put them in that question box at the end, please. So the agenda for today, we'll do a brief introduction to who we are as a company, CPG UK, introduction to the standards and regulations, different types of fire protection, the fire ratings that we look to achieve, run through briefly the fire stopping products, look a bit about fire practice, how not to install, and then about accreditations, technical information, and then I say we'll look at the questions at the end. So it is a brief overview. This isn't installer training. It's not too in depth. It's just to sort of give us an overview of what we do as an industry. So for us as CPG, we've got brands across the range and all the way through sort of the envelope of buildings. So it ranges through windows, walls and facades, through passive fire protection, flooring, roofing, waterproofing, the different brands within those. So today the brand we're looking at is the Nullifier brand, which is split down into two sections. You've got your intumescent coatings and your fire stopping products. Today we're only looking at the fire stopping side of things, so we do another seminar that talks about the intumescent coatings if you're interested in that one. So if we look at this slide here, when we talk about the fire triangle, what is fire? Well, with the fire triangle, with the image on the left, it's formed of three elements. You have to have heat, fuel and oxygen to be able to allow a fire to build up and to carry on burning. It can't exist without all three of those elements together. And that's basis is what we base fire protection on, is emitting or limiting one of those three elements so that the fire cannot continue. On the right, we have, it's called the fire tetrahedron. All three elements come together and then that's forming a chain reaction and then that creates the fire. So that's where your tetrahedron comes in. So what happens during a fire? So you get a large build-up, increase in temperature and pressure, and those two things are important. It's not just the temperature that we're looking to inhibit, it's the and to sort of test against, it's the pressure. So we have to make sure when products are installed, they can withstand any sort of pressure that they would come under from the fire, and that remains high for as long as that fuel and oxygen is present. And then what we test to now, which is the more onerous EN standard testings, we have to consider that pressure variance, which wasn't probably because there's so much in the British standard test that used to be used. And it would be more of what we would see in a real life fire situation. So it makes passing an EN test much more difficult than those older standards. And that's a good thing. Obviously, the products will be more robust to be able to pass these tests. And then your different types of fire. So you've basically got two types of fire. You've got your cellulosic and your hydrocarbon. What we're talking about today and the products we talk about today would be used in cellulosic fires, not in hydrocarbon. With hydrocarbon, it's a different type of fuel. So you'd be looking at sort of oil and gas facilities. They're fueled by hydrocarbon materials. They get to very high temperatures very sort of quickly. Explosions are expected in those type of fires. So the products we're talking about today wouldn't be suitable. In cellulosic fires, they're fueled mainly by cellulose-based materials, so that includes papers, textiles, woods, anything that sort of is combustible and would be expected in a general sort of residential or commercial building, but it has more of a build up to the temperatures and the spread of fire than you would find in a hydrocarbon. And then whether you're a contractor, I mean, I know we've got a mix on today, whether you're contractors, engineers, architects, or you're just looking for some information on the subject, the two terms of reaction versus resistance can be confusing, but there's a distinct distinction, should I say, between the two. The reaction to fire, that evaluates the specific materials that are contributed to the fire. So again, looking at the materials, indication of how it will respond, how it's going to flare, how it's going to sort of add to that fire. And And A1, it doesn't fuel or contribute to the fire at all. B is little fuel and very low contribution to the fire, but they cause a flashover. And there's also sort of smoke capacity and flaming droplets that are measured. Whereas resistance to fire assesses a system's ability to resist the penetration through the system or the product, and then prevent that temperature rise between the exposed and unexposed sides, should I say, in a fully developed fire. That's represented by our integrity, insulation, and load-bearing capacity, which we'll discuss on one of the other slides. So with the standards and regulations, we've got approved document B, a regulatory reform order. I'll just put them all up here so we can see them as we move through. So prevent and control the dangers of the fire standards, regulations, legislations were created. So approved document B, that's one of the main ones that we used in the passive fire protection industry. And it discusses sort of the means of warning and escape, the internal fire spread within the linings and the structure, and the external fire spread. So it allows for the sort of access facilities for the fire service to come in. When you're looking at the regulatory reform order, that's a document that came into power in 2005. I think they unified it, I think it changed it in 2013, I think it was. And it's a means to sort of put the onus of the fire protection responsibility on an individual. And it's usually the building owner, and they have to make sure that they check and ensure that means of fire protection are in place in accordance to that building requirement. And then you've got testing in the UK according to sort of BS 476 parts 20 to 22 for load bearing and non-load bearing fire seals. That's been replaced by the unified standard of BSEN 1366 parts 3 and 4. So sort of for penetration seals and then linear gap seals respectively. They're basically the standards products are tested to and against to conform compliance. And then the CE marking, it's not come up yet, let's just try and get that to come up. Yeah, that's now a requirement for all products used in construction, and fire protection is no different. So it needs the UKCA marking. I think the deadline's now been extended to 2025, but we're sort of, as a company, we're working towards that at the moment. So that's sort of an overview of all the legislations that are in place and the standards. So to tackle fire, you've got two different elements normally in a building. You've got your active fire protection against, and then you've got your passive fire protection. So active fire protection is things such as your sprinklers, alarms, carbon monoxide detectors. They're things that need to be activated. So they'd need an actuator or someone to get them to sort of work and to operate. With those, the systems, they're usually sort of operable by a manual triggering, either from control room or fire alarm call point as well. So there's always something that's, it's got to be an active way of dealing with the fire. The passive side of things, which is what we're talking about today, it's simple. It's by using certain materials to protect that structural element of the building and to create compartments to prevent the spread of fire. And it carries out its function without requiring any manual or automatic initiation of it. So that's why, because it's passive, those products are in place and that will not do anything until there is a fire. Your types of passive fire protection, so you've got your structural protection and your compartmentation. So structural is looking at looking after and protecting the structure of the building itself, and then your compartmentation is looking at stopping the spread of fire and smoke from one compartment within the building to another. And for buildings constructed using sort of structural steel, there are three main methods of protection. You've got board protection, and it used to be one of the most used methods of protecting steel, but now it tends to get used in sort of higher fire ratings and for specific sort of steel locations where it's deemed necessary to use a board. You've got your set spray, or cementitious spray as some call it. That was used to sort of mainly obtain up to sort of 4 hours fire protection, and it's used as a non-reactive cementitious spray. And then you've got your intumescent paint systems, currently probably the most commonly used out there. And it's sort of various benefits it gives you. You can do on-site, off-site. It gives you an aesthetic appeal. The ease of application and sort of the thin layer you need to put on, always sort of, push it down the route of intumescent if possible. And then Other types of structures such as concrete, timber, SFS, they'd all require protection. Concrete doesn't burn, but it does spool in high temperatures, and after a certain period of time would lose integrity. And some products are designed to improve the fire rating of that concrete structure, should it not have inherently fire rated to the required design. And then when it comes to CLT, sort of cross-laminated timber, the timber char rate must be considered, and when we generally assume the char rate of timber to be 1 mil per minute. But again, when we're looking at these kind of things, the structural engineer needs to be in place to sort of tell us what the fire rating needs to be. And then your compartmentation. So a fire compartment, it's a building or part of a building, and it comprises of one or more rooms, spaces, stories, so horizontally, vertically, and it's constructed to prevent the spread of fire to or from another part of the same building or an adjoining building. So the basis of it is to subdivide that building into areas of manageable risk, and it provides sort of adequate means of escape and to provide fire separation for the adjoining buildings. And to achieve that, we need to put in a measure of control called a fire rating. The primary means of limiting growth and spread of fire within a building is that a fire compartment it's a group of rooms. It's constructed in such a way that your compartment is constructed in line with building regs and alongside approved document B. As manufacturers, we don't get involved in saying what the fire rating is, but what tends to be looked at from site view and design view is that you look at your escape routes. Do we need to have protected or firefighting staircases? Are there protected corridors, dead end situations where people might be required to sort of utilise some form of airlock or sterilisation system to make their escape? And then sort of things like vertically rising shafts that penetrate through horizontal compartmentation, so lift shafts, service risers, that kind of thing. And then have we got walls common to 2 or more buildings? So is there sort of different tenants, etc. And what's the intended activity within that building? So we've got high risk. Have we got sort of things like plant rooms, workshops, laboratories, kitchens, that kind of thing? They will all add to the reasonings behind what the fire rating would be and where we're putting the fire walls in there. Now, this slide, the main reason for fatalities, as we all know, in fire is smoke. So this is sort of just to basically show you that in a fire situation, you've got an office there, and let's say that's a 3 metre by 3 metre room. And how long would it take that in that line, the pink line, there's a gap there that's supposed to sort of be the size of a pencil. So, and it's about travelling, smoke travel from one compartment to the other. So if we put on here, there's a fire breaks out in the room next door, how long would it take basically for that fire through that hole to fill that room? And I normally ask, when we do a Teams call, ask people to tell me what they think it is, because it's Ramadan, you can't tell me, but it's basically 3 minutes and 20 seconds. And that's based on the speed that smokes travel with the pressure created from that fire. And I guess this is just to highlight the importance of compartmentation, and now something like a small opening could cause major problems. So when we're looking at compartment, it's not just the big voids where we're putting fire bats and that kind of thing through. You've got to look at the small openings as well. So within your fire rating, we're looking at 3 sort of elements. You've got your load bearing capacity, your integrity, and your insulation. So your load bearing is it's a period of time before a structural element loses its structural capacity. Your integrity is the resistance to the fire penetration, so an ability to maintain the integrity of the element. And then your insulation, so the resistance to the transfer of heat from one side to the other, and to an ability to provide insulation from that. And they're all defined in both BS 476 and BSEN. And it's different fire testing standards, including parts 3 and 4. The fire rate is determined by the fire strategy, not by manufacturers, and they follow the guidance on approved document B and other regulations to get to that. So some elements require higher fire rates than others, such as high risk areas or the content of the building. So you could have storage of things like combustibles, like it could be chemicals in a room, or it could be just be a lot of combustible textiles, that kind of thing. And that will add to whether we're looking at getting either integrity or stopping the passage of that heat going through as well. Because as you can imagine, if you're storing combustibles on another side of a compartment wall, that could have the ability to, just from pure heat, to start and ignite a fire on the other side of the wall. To give you an indication of what we tend to look at, and this is just a sort of a rough guidance. So typical levels of passive fire protection that we tend to see are something like you know, a two-story building that's got maybe shops that are less than 5 meters in height. You could get something up to 60-minute fire rating coming through. The bigger the building, the more people are in it, the harder it is to evacuate it. You could go up to sort of between 60 minutes and 90 minutes for anything between 18 meters and 30 meters. Anything above 30 meters tends to go up to 2 hours. But this is all affected as well by whether, if it's got sprinkler systems, or the strategies is changed. So this is just a guidance. It's not a hard and fast rule. So fire stopping materials. They're designed to reinstate the partition walls or floors to the designed fire rating. And then, so when M&E guys come in and make penetrations through that firewall or floor, the opening that's created, that's considered a breach, that integrity of that compartment, and that's got to be reinstated. So to achieve that, fire stopping products have to be discussed, and will be discussed today. So linear gaps can be the same thing in fire compartments. They're also considered a weak spot through which fire can breach. So that also needs to be rectified when you're looking at using your fire stopping products. So the main product within most people's ranges is the fire bats. It's one of the most commonly used fire stopping products. Can be used in a variety of applications, can be looked at sealing in walls and floors with different materials. Tends to be more in walls than it does floors because of the load bearing capacity normally needed in a floor. And they're used in conjunction with other fire stopping materials, so to achieve fire protection. So it could be alongside, and it would be alongside mastics, but it could also be collars, sleeves, that kind of thing. They're formed of like a mineral fibre bat or a base, and then it has an ablative coating on it on both sides, which basically contains water molecules, and those particles evaporate during a fire and cool down the bat. So combustibles and non-combustible penetrations are going through that bat. The bat has to be cut and friction fitted around those, and then those have to be sealed and have either a closer device if they're combustible, or a non-closing device, or a fire stop around it if they're non-combustible. The installation of the bats and deciding the number of layers of bats, how many to use, would be based on quite a few things. So we can't cover it all today, but you'd be asking the questions of what's the fire rating, what's the size of the opening that you're looking at, and the construction of the opening. What's the type of penetration that's going through there? So is it combustible, non-combustible? Is it PVC? Is it PVCU? Is it copper? Is it, you know, what's your acoustic ratings that you're looking for? Are there any acoustic ratings needed? Does it, you know, need to look a certain way? So as you can imagine, with all these questions being asked, there's many sort of different installation details that are available based on tested scenarios and certified installations. So we'll always get as much information together about the install. We tend to get people coming out going, right, we've got a plastic pipe going through a wall and we want 60 minutes. Right, okay, so is it 60 minutes integrity? Is it 60 minutes insulation? What's the wall made up of? What's the pipe made up of? What's the opening size? All these things are considered because testing is quite specific. And if we pull away from that, we then need to go to sort of a technical evaluation, which would be like the old ad hocs. So we're basing it on tested evidence, but that you're not going to get a completely tested scenario for every single penetration out there. But we, you know, as much information as we can get it as close as we can. You know, probably 60–70% of the time we can get tested details for it, but those other 30% you're always going to get on a job until they're designed a certain way. And even then it can be designed brilliantly and you'll get, you know, a builder going in there and smacking a hole through something that he shouldn't have done. But you've got to, it's important to remember that all those services going through fire seal, and they all must be independently supported as well. So just get as much information as you can before we sort of ascertain which products to be used. And then Intumescent expansion. Now, sometimes this video works, sometimes it decides it doesn't want to. Basically, before I start it, this is just a piece of steel in a furnace, and it has the lighter sort of browny reddy colour bit at the top is just your prime steel. The white bit then strip is your intumescent, and that intumescent is carried on underneath the black part. The black part is covered in a top seal, just to give it a colour. And this gives you an indication of how an intumescent works. So intumescent comes from the Latin intumescere, which means to swell. So let's hope that it shows us how it swells. Oh, it's working today. I hope it's working your end. So as you can see in the file, this is speeded up. It's slightly in sort of inhibited by the top seal for a start to stop it from, I mean, this is sort of seconds. The top seal will burn away and then the intumescent swells up. So this is the same sort of thing that's used in intumescent coatings for steelwork to insulate the steel itself. It's the same that's used in things like your collars that would go around a pipe, and then once the pipe melts, fire is in the collar and it will fill that gap. So it gives you an indication of how they work. The same with graphite sealant. So you put a bead of graphite sealant around, it would have this graphite in it, and the penetration that runs through, if it's combustible, it would melt, and then this would fill the gap that's left. Same as sleeves. So it's all the same sort of products that are used within them. It just gives you an indication of how much they actually swell up. Then you go on to things like the fire compound and using a strap within a floor. So mainly used in floors, can be used in some wall situations. It has got load bearing capacity. You install ours up to sort of 100 mil, well, it's not up to, it's 100 mil depth. And it's where you'd be getting expected footfall and that kind of thing. The strap, again, with the intumescent material within that, that's used around the pipe. So it's using the compound as to hold it, to allow once the intumescent swells, it will go inwards to where the pipe was. It's not going to go outwards because it's pushing against the compound. So you've got your fire stop and allowing a load bearing element in there. And then going back to that previous slide when it's talking about load bearing, if you're wanting load bearing, this tends to be the product you'd go to. And then in the case of the combustible pipes, they melt and that strap again will fill in with the intumescent material. Compound comes in a powder form. It's just mixed with water, poured into a hole in the floor with a shutter bat used to allow it to set. And then the compound itself holds itself against the substrate, so it gives it its own strength within the substrate. So the shutter bat basically becomes sacrificial and would just burn away. And then also the bat would control the amount to make sure that you've got your 100 mil pour in there as well. So some people ask why compound and not concrete. So the main reason is that pouring concrete is that concrete shrinks when it cures and compound expands to ensure a proper seal. So concrete, if it shrinks, could cause cracks, which could cause smoke to come through. So with the compound, you don't get that. Now, sleeves and collars, exactly the same thing with the intumescent within them. These just give, sometimes it's either easier or just the way the wall's being configured, or that there could be something with sleeves where you're looking at putting multiple services through. They're just again closing devices used in conjunction with bats or compound, and they contain that same material. They can be used sort of directly into plasterboard walls as well. They tend to be used in instances where pipes either too large to use a strap, or it's just more convenient due to the size of the opening or restrictions that are in there. But again, they just do exactly the same job. Just again, we need to look at what's tested, what we can go through, and then decisions can be made as to which is going to be more preferable on site. Now, for fire-rated ducting material, mineral fiberboard is used here, and it's encapsulating that ductwork and providing it with required sort of fire rating. Dampers within ductwork, they need to be given sort of special consideration really, and you must always consult the damper manufacturer for the method of protecting those. It's no good going to a manufacturer of fire protection materials. You need to go to the damper manufacturer, because that's another question that we're always getting asked. Cut out the middleman, just go straight to the damper manufacturer, and they will let you know how to sort of what method should be used. So cables and sort of cable management devices, they vary. Certain care that needs to be taken in considering the fire protection method you're going to use there, as sort of the cable materials just inherited by what they're normally made out of, can include high heat transfers such as sort of copper, that kind of thing. And that would affect the insulation rating of what's going through. So in that example, sort of a cable sleeves used for several cable penetrations there. Batten mastic could be used for a cable tray. Smoke seals also used inside the sleeve to prevent smoke from travelling through before the sort of intumescent works. And the cables and sieves in general need to be mechanically supported independent of that fire seal. But again, is another way we can, another fire protection method that we could use. So slab edge and rain screen cladding. Now, depending on whether you're needing ventilated cavity or a non-ventilated cavity, whether it's horizontal, vertical, what the size of the air gap is, all these questions would need to be asked depending on which product you'd then look at. But it's basically where there's a gap present between the edge of the slab and the cladding or the curtain wall, and that presents a breach to the fire compartment, and then would be a risk vertically of fire spread. Sort of a back deal could be used to close the cavity, allowing for some sort of movement, but other sort of details are available for rain screen, where normally they'd want a ventilation cavity of up to sort of 50 mil. And then an intumescent, again, an intumescent type material used to close that cavity in a fire scenario. So it would be attached to the slab, and then it would still be allowing air to travel through and condensation, that kind of thing. But then in a fire scenario, the intumescent would swell up and it would fill that gap vertically. So between that and the cladding. All fire stopping products are generally considered inert, so they don't require any maintenance or anything like that. They just need inspecting, making sure they haven't been damaged by either water or mechanically damaged or that kind of thing, or just been moved. And if they haven't, they could be for the be there for the lifetime of the building, sort of up to 50 years kind of thing. So again, that's another question that sometimes gets asked. And then in the latest review of sort of building regulations in light of obviously events that have happened, the fire stopping products, they are exempt from the combustibility ban, as some of the elements like the intumescent require charring or reaction with fire to sort of function. So if anybody's asking about the combustibility ban, then our products aren't included in that within fire protection. So CPVC, so all CPVC plastic parts require a closed device. And then it's like strap, HP mastic, or for us, sort of HP blue mastic. And we must be on sort of a manufacturer approved list. We are on one of them, we're on the Lubrizol one. We're not currently on the Spears one. We have got, if you speak to our technical team, they would be able to advise what we would recommend from that side of things, of what to do. But the main ones tend to be in the UK, Lubrizol or Spears. They're highly reactive products, the CPVC pipes, and multiple precautions have to be taken when installing them. So down to not installing them on the floor and making sure things like, even down to deodorant, can't be touching them. So not all CPVC pipes are orange. Sometimes people make that mistake, but maybe they're mostly commonly associated to that. There have been white and grey variants though, so always please ask the questions as to whether and what type they are. Tile practice, these are just a couple of ones. They're live sites, they weren't sort of mocked up for this, so it's a life safety measure. Please make sure that they're installed correctly. With bats, you shouldn't see any of the bat itself, you should just see the mastic or the ablative that's on there. It looks like on the picture on the left, there's, I don't know whether it's foam that's been squirted in there, who knows. The picture on the right, they've used fire foam alongside a bat. That's a complete no-no. Fire foam's normally only tested in static linear joints, nothing to do with any penetrations or alongside bats, anything like that. So keeping an eye out on site, making sure that we don't want sort of lives and financial losses through things like products like that being installed. Fire protection should always be carried out by trained, accredited and competent professionals. So third-party accreditation is one way of installing that confidence within people and making sure that the fire protection installer has been trained, being audited on a regular basis for quality assurance, along with the golden thread now. It just gives that sort of peace of mind alongside your manufacturers to make sure the manufacturers are using third-party accredited products. So yeah, we think that we're going to look at these sites now and these aren't going to be about anymore, but unfortunately it's not the case. And that's another one there where someone decided a plastic bag was going to do the trick. It might hold back cold smoke for a while, maybe not. Anything else, forget it. So to ensure that specified products are sort of used correctly, site records and third-party audit documents, you make sure that all of these things are in place. It takes away the onus from whoever's specifying. If you're using third-party accredited products and third-party accredited installers, it takes that bit of that onus away from further up the line when you're looking at design stage. Product identification, I mean, added measures have been put in place by some manufacturing companies, us being one of them, to ensure that the products can be identified either during or after a project's been installed. We did have one down in London where it was proved that probably 3,000 square meters of, or linear meters, should I say, of mastic turned out to be something that somebody had bought online and wasn't the right product. And we could do that by, if we look at the next slide, using, for ours, it's a traceability tool. So the ablative coating is basically on a batten in the mastic. It's got a pigment in there that causes like an ultraviolet light to shine brighter when it goes over it. And that helps us to sort of achieve compliance and installs confidence when you're specifying materials to know the product that you've specified is what's being installed. So again, if I try and get this to work, on the left-hand side there, you can see it glowing in purple. And that was on a bat that was bought on eBay that wasn't one of our bats. And then on the right is one of our bats. As you can see, it's a completely different, brighter colour. It's almost like a blue. So again, it's just making sure compliance is in place. It's very important that specifiers make sure it's aware of what products subcontractors are using. So as in many industries, it's possible to cut corners, but this isn't an industry that you should be doing that. Make sure the subcontractors using the products where certification is available, so you've got all that backup paperwork, and for inspection where required comes from a reputable source. So it's not every job's going to be checked by a third-party accredited company, but if they're third-party accredited, then they could have checks come and done on jobs if they're sort of a large enough job to sort of sustain that. And then making sure that all the records are taken from the installing subcontractors. That should all form part of the CDM submission anyway at the end of the project. It's not something that's new to installers. It's something that's been requested. We do have some new contractors coming in that can't put this into place, but you just need to be making sure with the golden thread that the installer's competent. The manufacturer installer training is not the answer. It's invaluable, but it's not the answer. You need to be looking at third-party accreditation. It can be, there's many out there, but we tend to sort of recognise FIRAS, LPCV, IFC. Those tend to be the main ones that people will join. And then looking at all applicators, so making sure that they've been trained in application of those products. It enables them to ensure correct preparation, application in the right environment, and they should also check that the right level of protection has been achieved. So the relevant sort of MBS clause for the specifiers on here is the M61-230 clause for the correct applicators personnel being used in a specification. So again, photographing work, making sure that they're maintaining those records. You should be able to see what they've installed, who's installed it, when it's been installed, and then have that work signed off if necessary on a project. The ASFP is the Association of Specialist Fire Protection. That's a governing body that we sort of all puts guidelines out for the industry. They also conduct contract training and accreditation. It's very useful. Many of our staff have been on this, and also installers tend to go on that, but it's open to all. So, anybody can go on that. With the ASFP, I mean, they were established back in 1975. So, to support the activity of the industry, and it looks at sort of all the forms of built-in fire protection. When they're sort of giving guidance on all aspects of that, they can also offer technical support and impartial advice. So almost all reputable material manufacturers and contractors are members of the ASFP. So it's like a sort of a regulatory area that they're looking at consulting bodies. It's a good document to go and look at if you look at the ASFP library for further information for anything within the industry. And then all manufacturers and suppliers, we should be committed to ensuring that our manufacturing and supply are adhering to the latest rules and regulations, if you like, plus taking sort of forward steps towards maintaining a sustainable future. Trying to use non-hazardous raw materials for production of coatings and sealants. Many of the raw materials used in sort of fire bats, for example, they can be recycled and reused, produce new bats. The products should last for the lifetime of the building, which saves on maintenance costs. As I say, they're inert, as we talked about before. We're looking at things like moving from plastic mastic tubes onto using foils, which again will help towards maintaining that sustainability of cutting down on plastics on site. And there's various things that are, other manufacturers as well will be working on. So today, summarise, so you should have a basic understanding of fire and the different methods of protecting against it. Like I said before, it's very basic overview. You're not going to be installers from this training. Get an idea about passive fire protection, the different systems used to achieve it, and then the main regulations, legislations for fire protection, and how to spot and avoid substandard fire protection. So it is only an overview. We do a 3-hour training that's more in depth. There's your bibliography there. So again, you're looking at your Proof Document B, the ASFP Red Book, which is available online. They also have your TGDs, technical guidance documents on there. You can go on REBA's website that gives you more information. So there's a whole plethora of, information out there that can be dug into. But like I say, if you wanted to do more in depth on fire stopping, we do have a 3-hour installer training that goes more in depth to each product. So thank you for attending. Managed to do that in 40 minutes. It does give us 5 minutes just to see if we've got any questions. Let me have a quick look. Can't see anything in there at the moment. No. All right, well, if you do have any questions and something crops up, let me just put the last slide on for you quickly, because it's got on there our helplines. So you don't have to put fire stopping help, you can just put fire help. It goes to the same address, so firehelp@cpg-europe.com, and then that's our technical helpline on there. So if you want to make a note of that while that's still up. So for any on the fire stopping side of things, if there's any technical questions, feel free to go onto that email address or ring in. I would say probably best to email, because the team are very busy and can get back in a timely fashion with the emails. They might not answer the phones that quickly, depending on how busy it is on certain days. So thank you for attending today, much appreciated. And hopefully we'll speak to you again soon.